In the solar system, most planets follow a similar pattern of motion. While orbiting the Sun, they also rotate on their own axis from west to east, that is, counterclockwise. However, there is one planet that does not follow this rule: Venus. Venus is the only planet in the solar system that rotates in the opposite direction on its axis. This unique feature sets it apart from all the other planets. On Venus, the Sun rises in the west and sets in the east, meaning everything appears to operate in reverse. Venus's reverse rotation has long been a subject of curiosity for scientists. This motion is technically referred to as retrograde rotation. In other words, while Venus rotates clockwise on its axis, it continues to orbit the Sun in the same direction as the other planets. Moreover, one full rotation of Venus takes 243 Earth days. This is even longer than its orbital period around the Sun, that is, one Venusian year. In other words, a day on Venus is longer than a year. So why is this the case? There are several theories regarding the cause of this reverse rotation. The giant impact theory. It is believed that Venus may have collided with another celestial body in the distant past, and this massive impact could have reversed the planet's rotation direction. Atmospheric drag theory. Venus's thick and dense atmosphere may have gradually reversed its rotation over time due to atmospheric friction. This unusual rotation becomes even more striking when combined with Venus's other characteristics. Its surface temperature is around 470 degrees Celsius hot enough to melt lead. The atmosphere is composed mostly of carbon dioxide and creates an intense greenhouse effect. These conditions make Venus an extremely hostile planet in terms of habitability. Venus's retrograde rotation is a striking example of the exceptions to the general order within the solar system. This behavior of the planet is not just an astronomical curiosity. It also sheds light on research related to planetary formation, dynamics, and atmospheric evolution. As scientists strive to understand the reasons behind this unusual motion, they simultaneously gain a broader perspective on how planets evolve. The extraordinary situation observed on Venus serves as a reminder of how much remains unknown in the universe. Venus's retrograde rotation is a very striking feature in the solar system. However, it is not truly a unique exception on its own. Every planet tells a different story through its rotation speed, axial tilt, and pattern of motion. Venus's unusual movement is just a small example of the diversity that exists in the universe. For example, Uranus rotates almost on its side because its axis is tilted by about 98 degrees. This makes Uranus's seasons very different from those of other planets. One of its poles receives sunlight for years at a time, while the opposite pole remains in darkness for a long period. This peculiar rotation makes Uranus unique in the solar system. Mars is known as the Red Planet and features massive volcanoes, deep valleys, and polar ice caps on its surface. A day on Mars is very close to that on Earth, lasting about 24 hours and 37 minutes. Additionally, Mars can experience huge dust storms, some of which grow large enough to cover the entire planet. Jupiter is the largest planet in the solar system and is home to a gigantic storm known as the Great Red Spot, which has been ongoing for centuries. This storm is even larger than Earth and demonstrates the dynamic nature of Jupiter's atmosphere. Jupiter has many moons, with Europa being especially significant in the search for life. Saturn is known for its mesmerizing rings. These rings are made up of ice and rock particles, giving the planet a dazzling appearance. The structure and origin of the rings remain subjects of ongoing scientific research. Finally, consider Mercury. As the closest planet to the Sun, Mercury experiences extreme temperature differences. Daytime temperatures can reach up to 430 degrees Celsius, while nighttime temperatures can drop as low as -180 degrees Celsius. Its rocky and cratered surface resembles that of the Moon. All these planets, like Venus, have extraordinary features that highlight just how rich and diverse the solar system is. Each one opens new doors to uncovering the mysteries of the universe. What if Earth started rotating in the opposite direction? How would this change our lives and the nature of our planet? Currently, Earth rotates on its axis from west to east. This rotation causes the sun to rise in the east and set in the west. This daily cycle creates day and night and determines the main directions of winds and ocean currents. Earth's rotation has a profound impact on climate and ecosystems. Now, imagine Earth rotating in the opposite direction from east to west. The first and most obvious change would be in the movement of the sun across the sky. Instead of rising in the east, the sun would begin to rise in the west. The cycle of day and night would be reversed. At first, this would be surprising and difficult for people to get used to. But Earth's reverse rotation would affect more than just the direction of sunrise and sunset. Wind systems in our atmosphere would completely change direction. Earth's current rotation shapes air movements. For example, winds blow counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. With a reverse rotation, this pattern would be reversed. This change would affect the paths of storms and weather systems. Hurricanes, typhoons, and other major weather events would follow different routes. Some regions might experience increased storm risks, while others might see a decrease. At the same time, ocean currents would also reverse. Currently, warm water currents in the Atlantic move northward, while cold water flows southward. If Earth rotated backwards, these currents would change direction as well. This would alter the distribution of ocean temperatures and cause major shifts in the global climate balance. For example, the Gulf Stream, which today helps maintain Europe's mild climate, might weaken or even reverse. This could turn Europe into a much colder place. Such changes would reshape ecosystems worldwide. Marine life migration routes would shift, and vegetation would adapt to new climate conditions. Although reverse rotation would not directly affect Earth's magnetic field, changes in atmospheric circulation would impact the planet's natural cycles over the long term. In conclusion, if Earth rotated in the opposite direction, life would continue. However, with the reversal of winds, ocean currents, weather patterns, and climate, nature would find a new balance. Like the retrograde rotation seen on Venus, such major changes in planetary motion play important roles in planetary evolution. Earth's current rotation direction and speed are part of an ideal combination that makes it habitable today. As we continue to study these cosmic wonders, we are reminded that the universe still holds many mysteries waiting to be uncovered. Each discovery opens new doors to knowledge and inspires us to look beyond what we know, fostering a greater appreciation for our place in the cosmos. Thank you for joining me on this journey through the fascinating dynamics of our planetary neighbors.